Okay, go to share screen. Go to our class. And we're going to be talking about atomic number and mass number. All right, and a few other things. Okay, we've talked about atomic number, which is the number of protons, and we're going to add to that mass number. So one of the things we talked to, everything we see is made of atoms. If we can see it, it's reflecting light, and therefore it is made of atoms. All right. So it leaves us one more question though. What are atoms made of? I mean, think about it. We need to know what atoms are made of because it explains a lot about the periodic table. We've already talked about protons and electrons. All right. So here we have protons. Those are the orange dots. Out here, we have the electrons. Electrons are in orbit around the nucleus. The protons and the neutrons are in the nucleus. And what we're really talking about today is the neutrons more than anything else, because we've talked about these other things. Okay. Protons have a positive charge, and they attract things with a negative charge. Okay, I'm admitting some more people. So protons are in the nucleus. They have a positive charge. Neutrons are also in the nucleus. Now, why are they called neutrons? Because they have no charge. Neutron means neutral. They have no charge whatsoever. Electrons surrounds the nucleus, and they have a negative charge. And in our daily life, we cause this electricity. Okay? Electrons are the cause of electrical current that turn everything on. Okay? So a neutron has no charge. That's where the name comes from. That's one of the big points I want to drive home today. Because we talked about the other things, but we haven't talked about neutrons yet. Now, the role of neutrons. The protons, which are in red here, are positive, and positive charges repel each other. If you only had protons, the nucleus would not stay together. The neutrons are there, they have no charge, to kind of get between the protons so they don't repel each other. Now, the number of protons, that's the atomic number. The atomic number determines what type of element an atom is. The atomic number, because it's positive, okay, it attracts neutrons. That's the atomic number. The neutrons plus the protons, though, is the mass number. Okay? That's the mass number. How many of them there are together? So remember, the atomic number is just the number of protons. They mean the same thing. All right? The mass number is the protons plus the neutrons. Okay? Protons plus neutrons is the mass number. You just need to know that. For every element, the number of protons, the atomic number, this number down here, doesn't change. It's always the same. That's why on the periodic table, the elements are listed by increasing atomic number. All right. Now, here's the new thing we're kind of putting in here. The number of neutrons can change. Protons for each element remains the same. The number of neutrons can change. Now, what's an example of this? I mean, I don't like to just talk about things. I kind of like to show you. Well, I'll show you here with carbon. The vast majority of carbons, well over 90% of them, have 6 protons and 6 neutrons for a mass number of 12. A few carbons have 6 protons and 7 neutrons for a mass number of 13. These are very rare, but they're out there. And another type of carbon, 6 protons, 8 neutrons, that's called carbon 14. You may have heard of carbon 14 dating, because carbon 14 will degrade into something else at a predictable rate. Okay? They can use carbon 14 dating for some things. So carbon 14 has 6 protons and 8 neutrons. Now notice the number of protons remains the same, because if the number of protons changes, it's no longer carbon. The protons has to be 6 or it's not carbon. Does that make sense to everybody? All right. So we're going to watch a little video related to this. Oops. I guess this does not support the video function like my laptop does. So I guess for today, we're not watching the video. Now, some isotopes are unstable, such as uranium-235. Uranium-235, because it's larger, the stable form of uranium actually has more neutrons. If something hits it, like a flying neutron, uranium-235 will fly apart and release a lot of energy. And that's where we get nuclear energy from. Okay? So, okay, here it looks like the video's working. This is how we get nuclear energy, and there's a good video on that. Hopefully this laptop supports it, and it does.
Seoul's newly redesigned City Hall is going green. Up on its rooftop are just over 1,000 solar panels that produce electricity and heat the building's water. Kook Jong-yen heads City Hall's energy division. He says the panels provide 28% of the building's total energy needs, but he hopes they have a greater symbolic impact.
We want to encourage the private sector to invest in renewable energy too. We can show them how the solar panels work here in City Hall in hopes they will follow our lead.
South Korea has limited natural resources. The World Bank estimates that 82% of Korea's total energy consumption comes from foreign imports, mostly coal and petroleum. Park Ji-young, an energy analyst at the Asan Institute for Policy Studies in Seoul, says developing green technologies is one way to lessen that dependency.
Renewable energy source is inevitable for Korea to maintain its sustainable development as well as the quality of life to the public.
Park says green energy projects like those at Seoul City Hall should be encouraged, but those alone cannot satisfy all of the country's needs. Nuclear power plants produce about 1/3 of South Korea's electricity. There are currently 23 facilities, and over the next decade, the government plans to build 9 more. The reactors remain a key part of South Korea's roadmap for energy security. Kim Jong-kyung is president of the Korea Nuclear Society. Despite heightened concerns over nuclear power following Japan's Fukushima disaster, Kim says nuclear reactors are in fact a green technology.
CO2 배출량이 이 뉴클리어는 기준을 보통 CO2 배출량은
The CO2 output of nuclear power is only 10 grams per kilowatt hour. Emissions from liquid natural gas, for example, are 55 times higher. That is why nuclear energy is green energy. Of course, there are safety concerns, but as long as those are resolved, nuclear is the cleanest.
수십 배에서 100배 정도 이렇게 차이가 나기 때문에 이건 당연히 그린 테크놀로지라고 볼 수가 있죠.
Safety concerns also have risen at some of South Korea's nuclear plants. In the past year, 3 reactors have been taken offline after fake safety certificates were discovered, and some government officials have been fired or jailed for accepting bribes from part suppliers. Back at Seoul City Hall, Energy Supervisor Kook Jong-yen says these safety and corruption scandals just make solar panels and other green technologies more attractive.
화석연료의 고갈을 앞두고 새로운 에너지원이 필요하고
This technology is developing very fast, and we have government support. So I think in the future, these types of renewable energies will replace nuclear and other non-renewable sources.
And Kook adds, when that happens, South Korea will be truly energy independent. Jason Struther for VOA News, Seoul.
Okay. All right. Go back to our presentation. So these isotopes, some of which radioactive, is a source of nuclear energy, and there is safety concerns about it. A lot of countries, though, right now are getting their electricity from nuclear power. All right. France is leading the world. They get over almost 80% of their electricity from nuclear power. South Korea gets over 30%. USA, a little less than 20%. But you can see there are some countries that are getting most of their electricity from nuclear power. So it is being used, and it's becoming more common. So here's another video. This just is more of a news article, but even countries you wouldn't expect to start using nuclear power are starting to. And this is a really good video about that.
At Echo Park Automotive,
We got to
our
skip through the
showrooms are open
commercial.
for business. Shop our inventory and complete most of.
Let's talk about the Gulf going nuclear. The United Arab Emirates is about to flick the switch on a nuclear power plant. It's the first of its kind in the Arab world, and not everyone thinks it's a good idea.
This is the wrong reactor in the wrong place at the wrong time.
So why has the UAE decided to go nuclear? What are the risks? And why is a nuclear research reactor in Saudi Arabia adding to the nerves? Chernobyl and Fukushima, they don't exactly make nuclear reactors an easy sell. What does help a little is that nuclear power plants generate energy without adding to global warming. So first up, here are the basics on how it works. At the core of the process is nuclear fission. When atoms split, they release energy. That energy boils water, which creates steam, which then spins a turbine to generate electricity. It's technology that originated in the 1950s, and it's evolved since then, but it's still risky and it's really expensive, especially when you compare it to renewable energy like wind and solar.
Every state has the right to determine its energy mix. The problem is this: nuclear costs are enormous. Renewables are between 1/5 and 1/7 the cost of nuclear.
It's why many countries seem to be powering down from nuclear energy. In 1996, global electricity generated from nuclear peaked at nearly 18%. By 2018, it fell to 10%. And in the Gulf, other sources of energy seem like no-brainers. There's plenty of sunshine, wind, and massive reserves of oil and gas. Many countries in the region are trying to diversify away from fossil fuels. The UAE already has one of the world's largest solar plants, the newer Abu Dhabi, with more than 3 million panels. And the UAE is pushing ahead with the Arab world's first nuclear power plant. The Barka facility is in the Emirate of Abu Dhabi, the UAE's capital. Construction has been going on since 2012, and it's been a long road of delays and overspending by billions of dollars. But now it's nearly ready to plug into the grid. In March, the first of 4 reactors was loaded with fuel rods. Once all 4 reactors are online, Barka is expected to generate up to 25% of the UAE's electricity.
24 hours a day, 7 days a week, to help power the growth of the nation.
In 2020, we will become the first country in the region to deliver safe, commercial, and peaceful nuclear power.
But keeping the peace in this part of the world isn't easy. It's a tough neighborhood. You've got Saudi Arabia, Iran, and Israel, a triumvirate of sworn enemies, and plenty of other rivalries too. That's made it hard to build trust. And when it comes to nuclear capability, there's a long history of secrecy here. Iraq and Libya both have covert nuclear programs. Algeria built a nuclear research reactor before inviting inspectors in. Saudi Arabia is building a research reactor too, but we'll get to that later. Iran has also been accused of secrecy. It's been cast by Western countries as the region's nuclear bad boy trying to develop a bomb. Iran has always denied that, but in 2002, it did acknowledge it was building nuclear facilities that it hadn't declared. In 2007, Israel bombed what it says was a nuclear reactor in Syria, but only owned up to it in 2018. And then there's Israel itself, which refuses to confirm or deny that it has nuclear weapons, though most experts reckon it has at least 90 warheads. Safe to say that suspicions over nuclear ambitions in the region don't come out of nowhere.
If you have a civil nuclear capacity, you can then start to go towards a military nuclear capacity.
Without getting too in the weeds on this, the leap from producing nuclear power to making a weapon isn't a big one. To make electricity, you have to enrich natural uranium to 3 to 5%. To make the bomb, it has to be over 90%. The higher, the better. But the facility needed for both is the same. Now, the UAE has worked hard to reassure people it's not interested in building a bomb. The country signed an agreement with the International Atomic Energy Agency, the IAEA, over a decade ago to allow inspectors in on short notice. And in March, the UAE's ambassador to the US reiterated the country's peaceful intentions, saying it won't enrich its own uranium or reprocess spent nuclear fuel. Here's what he said in the Wall Street Journal. New and better rules have delivered a new, huge source of clean power and reduced the risk of nuclear proliferation. But experts we spoke to still feel the idea of turning to nuclear energy just doesn't add up.
There are no economic or energy policy or industrial reasons to build a nuclear power plant. If states, countries decide to build a nuclear power plant anyway, then we have to discuss other issues that are actually the drivers for those projects.
It's not just about fears over a potential nuclear weapon. What if Barka gets attacked again? The UAE is fighting a war in Yemen. Here's what happened in 2017.
The UAE has denied it's been hit by a cruise missile fired by Houthi rebels in Yemen. The group's television service says they were targeting the Al Baraka nuclear reactor.
Firing the cruise missile at the UAE is an important qualitative leap.
There's an old saying, which is a nuclear power plant in a country is like a pre-deployed nuclear weapon for the enemy.
The idea is that targeting a nuclear power plant is like a nuclear weapon attack. And attacks on nuclear facilities in this region have happened before.
If you go back just even a few years, you can get to 13 aerial strikes against reactors in the region. This is not a place that allows for mere academic speculation about the possibility of someone else taking a whack at a reactor.
Last September, those same Houthi rebels who claim to have targeted Barka set their sights on Saudi Arabia. 18 drones and 7 cruise missiles hit Saudi oil facilities, temporarily knocking out more than half of the kingdom's oil production. You can see why people think it could happen to the Barka reactors.
I would say that they are as vulnerable as Saudi Arabia's Abqaiq facility was, which was protected by 3 layers of missile defense.
So they might be vulnerable to attack. But what if something just goes wrong? The Barka facility has been built by a South Korean company called KEPCO that's never exported a reactor before. And the UAE got a good deal. KEPCO's bid for the contract was reportedly about 30% cheaper than the next lowest bid.
So it's concerning that in a volatile area, these reactors are being built in what seems to be relatively a cheap and cheerful kind of way.
Paul Dorfman actually put together a safety report about Barka last year. He compiled a list of concerns, including the discovery of cracks in the containment buildings of all 4 reactors. And UAE officials only acknowledged it a year after they were found. They say they've been fixed, but concerns about the reactors don't stop there.
Doesn't have added on protection from airplane crash, missile attack. It also doesn't have what's known as a core catcher. It basically catches the core of the reactor. If anything goes wrong, it melts down.
And if something does go wrong, what happens to that radioactive material? Well, experts who've done modeling for oil spills seem to agree that what spills in the Gulf stays in the Gulf.
The contaminated water would be moved by the tidal currents. It would be flushed back and forth. So in other words, if you had a spillage here, it could take just over 2 years to get out of the Arabian Gulf.
Al Jazeera tried to ask officials from the UAE's nuclear and energy bodies about some of these concerns, but they never got back to us. And that brings us back to the issue of openness, not just from the UAE, but across the region. Take Saudi Arabia, for instance. It's building a nuclear research reactor, which some see as the first step in any nuclear program. And the kingdom says it plans to build 16 nuclear facilities by 2040. But they're moving ahead without IAEA inspectors checking the design and build.
Saudi have also started to make, and have been making quite consistently, deeply problematic statements about enrichment, in other words, proliferation, in other words, weapons.
And that takes on more significance given the kingdom's position on Iran.
Without a doubt, if Iran developed a nuclear bomb, we will follow suit as soon as possible.
Saudi Arabia and the UAE are allies. There's no suspicion of a nuclear arms race there, but there are other countries that don't get along, and anything can happen, whether it's an accident or something more sinister.
The point about these risks, these so-called low probability, high impact risks, is that they really do happen. And when they happen, you really can write off a lot of people's lives.
Low probability, but high impact. Nuclear energy anywhere carries risks. Now it's a reality on the Arabian Peninsula.
Attention homeowners, can we use your home to showcase our...
Okay. So that's pretty insightful of what's very current in the world, by the way. That is not an old article. That is something that's going on right now. And I, for students, I always like to show them things that are going on right now. So